Today we'll just have a short class to review those what we have learned in the previous lesson, and I summarized a lot of the common problems I see from last 2 years group. So I hope after going over these problems that I can help you to do a better job on your project. So before every project we start, what we have to do is to select a problem that is suitable for machine learning, a proper database, right? So the first thing we have to consider is what kind of problems are good to use a prediction model. So first type of problem, people, like we want to predict people's opinion about our candidate. The second problem, we want to predict people's vote on a candidate. Are both of them suitable for machine learning? So yeah, last year there was one student who used the survey data from the survey for his prediction model. So survey, usually you get people's opinion on a candidate. We don't predict people's opinion, right? This is unpredictable. Usually what we predict is the outcome, the events that happened. So that's a little bit different. So for example, on Amazon product, if you want to get the opinion, hey, whether people like this product or not, do we use the machine learning model to predict? We do a survey to customers, right? If you want to know people's opinion about this product. Rating, ask customers to rate this product. That's how we get people's opinion on a product. But we want to do, what machine learning can do is usually to predict, hey, how many people will buy this product or not. That's what we want to predict. So there's a slight difference between these two types of problem. That makes sense. So that's the first thing I want to clarify. So then we selected a problem we want to investigate, and then the next one is how can we start the project? Yeah, let's do yeah, I supposed to be an activity you'll discuss how you would start a project, and what are the steps you would do for your project. We can have 5 minutes to discuss this and do some group discussion. Discuss like how you would start the project after choosing a problem, choosing a database, and what steps you would do for this prediction project. And then we will go over these steps, okay, to see what's different between my answer and your answer. So that helps you like learn better and see the difference or anything, if anything that you may have missed. Okay. Of course, my answer may not be the correct answer, not be the best answer, right? So use 5 minutes, spend 5 minutes to work on it and to discuss these pairs. Right? And after 5 minutes, well, you come back to the slide.
These or what we're going to do on our own project?
What steps you will do? What are the steps you will do, like after you choose a problem and choose the database? How you will analyze the data?
Or big stuff. So. Not. It's really young. Better follow.
Feel good. Mesh, what's your answers? Your answer? Mm. What's your answer?
Just basically clean the data set.
Mhm.
So like go over
Mm.
what we needed,
Yeah,
delete null values, change types,
yeah, good.
just the whole process.
Uh-huh. And then next one. Did you list
Then
it?
you split the data set, training,
Uh-huh. Uh-huh. Yeah,
go take your model.
Yeah.
And get what you want to put in.
okay, yeah. Good answer. Yeah, I think I skipped some step in my slides. I didn't mention cleaning the data yet. That's important. Yeah, check the null values and then clean up the data if their types wrong. Good. Yeah, our group. What's your answer?
You
Anything to
basically
add?
said the same thing. Clean the data,
Okay.
two good problem
Uh-huh.
to evaluate, figure out what the target variable would be,
Okay.
start like with two big swaps.
All right. Yes. So I need to add a slide here, cleaning data type. On those files, changing the data type. testing values, what else can we do? For cleaning that data, what else can we?
Delete
Have-
unwanted features.
Okay, yeah. Did it include that somewhere, yeah. Could be either drop the columns or rows, or fill the missing data with a value.
Duplicate.
Check duplicates. Okay, good, yeah. Did we miss something? Yeah.
Code features.
Encode
Features.
the features,
So like
from
from category.
from text to, right. Do we think of anything else here? Oh, yeah, good. You are very good, better than me, okay? Thank you all for the help. So here, when we define the first step we need to do is to define the problem and then choose the right algorithm. Here, here what we have rendered is either linear regression or classification. Or here are 4 types of a target. What algorithm we use for each target, for each problem? Why?
So you're talking about like,
For each one, what algorithm will you use? What type of problem this is, and what algorithm you will use?
We doing the algorithm like which testing or?
Like this first thing is that this classification or regression problem, and then the second one is if it's regression or classification, what algorithm you will use? Peter, what's the answer?
or what?
For each target. So for each of these 4 problems, there's a classification of regression, and if it's a classification or regression, what algorithm you will use?
This is classification.
So you have to define the problem, each problem first, and then choose the algorithm. Target 1. Peter,
Like. Blood Cremor and a buffalo? No.
Well, no, I mean the algorithm for prediction models. No. Yeah, John.
Might be wrong, but would chart one be a logistic or logistic or regression? Not the linear regression, but the other one.
Logistic regression, yeah, you can use the logistic. Target 1 is obviously a classification. It's a categorical, right? So you could use logistic regression or KNN, K nearest neighbor, or decision tree. That one. How about target 2?
Regression.
So multiple regression. There are any different answers?
Hard to tell whether or not that's, which is 4 a day.
There are only three values, 1 to 3. 1 to 3. Yeah.
Would it not be categorical then? Because it's only 3.
Yeah, it should be categorical. Yeah. Yeah, some may, yeah, even it's 1, 2, 3, 4, 5. If it's not continuous, it should be categorical feature, categorical target, and you should use classification models. Okay. So what models we can use? Yeah, K nearest neighbor or another decision tree or other algorithm suitable for multiple classes, right? And not logistic regression. Target 3 is obvious. I guess that's an easy one.
Same for one,
Same.
first.
Yes, target 3 is same. You need to change it to 0, 1, code it. Target 4. Target 4 is a numerical, yeah. Show you the regression, linear regression. Okay, so be careful for this type of target 2. Okay, and 0, 1, a lot of students like with features coded as the 0, coded as numbers, and then they think it's a numerical feature, but actually it's a categorical. Okay, be careful of this type. It's categorical. We did this, and then the second step, after cleaning the data, the second step you could do is to plot a histogram to observe the features. So what we can learn, you could use the value counts to know the range of each feature, but I prefer histogram because it's more visualized and it gives you all the information in one plot. What can we learn from my histogram? No, good. I should have added this one. What else? We could also learn the data type of each feature. So from this picture, which features are numerical and which ones are categorical? From 1, 2, 3, 4, 5, okay, to 10. All right. Which ones are numerical? Which ones are categorical? In this picture.
CP is categorical.
You tell me the numbers of 1 to 3 to 10.
3.
2,
2 category.
2, 3.
10.
10 is, I believe 10 is numerical. A little bit different. It could be categorical.
6.
Yeah, 5, 6, and then 9. Yeah, these are all categorical. And it doesn't tell me. So when you see pictures like 10, you're not sure. You have to go back to check the feature. Okay, so to view the data and decide. It could be categorical. It could be numerical. And also from the histogram, you can know whether the target variable is balanced or not. That's important. And also you can see the range of each feature. Like if you are doing nearest the neighbor, that's important because you want all the features that to be on the same range, 0 to 1. Like this variable, if you are using k nearest neighbor, you know which variables you have to do the feature scaling. And also like Quinton said, check the outlier. So it would be good to use a histogram to observe the features. And for example, another thing is that if there's some feature that only have one bin, that means that it only has one value. Then this is if the feature only has one value, and then a few outliers, then this feature could be removed because it has all the same value for that feature, right? Uniform value. And then next thing we need to do is to do the feature engineering, and make sure when you job, I moved it to the previous slide, right? When you drop the features, when you drop any features, do explain the reason for that. I don't just drop some feature and so that helps you to avoid dropping those useful features. See, some students they just like to drop some features but didn't explain anything. That's not good. So next one is we need to examine the relationship of each feature and then the target. Why we need to do that?
This isn't that thing where if you have two things that correlate strongly with each other, you
Yeah.
can get rid of one of them.
Yeah, find the features. I'm sorry. That has a high correlation with the feature that has a high influence on the feature, right? And also it helps to reduce the dimensionality, especially when your database is large, it's important. Okay, so when you examine the relationship of each feature and the target, there comes the next part question. So what plot do we use? What test should we use for each feature? There should be the animation for this slide. When do we use a box plot? When do we use a scatter plot? And then the group bar plot. So there are only 3 types of problem. Like we just actually only 3, because it's either categorical target and a numerical feature. So 2 times 2, there should be 4 problems, right? Did I miss anything? Oh, okay. So I didn't miss anything. There are only 3 problems. But the last one would be numerical versus categorical. It's the same with this one. So three types of categorical versus numerical. What type of plots we use? Box plots, right? That's a typical box plot we could use. Sometimes it could be the targeted categorical. Sometimes it could be the targeted numerical, and the feature is categorical. It's the same. If it's a categorical versus a numerical, you should use a box plot. So this is a box plots generated from a data set. Do you feel is there something wrong with this? This box plot. Is there something wrong in here? What? Which one? 1 to 3, 1 to 3 to 6. There's something wrong. Which was wrong?
2, 4, 5.
2,
Very different.
4,
Or
2, 4, and 5.
because there's no,
Yes, so the problem here is I included some it should supposed to be numerical versus categorical 0 and 1, right? And I included some categorical variable here as well. So like this one, homeowner only has the values from 0 to 1. Probably only just 0 and 1. And this one the same.